Yeah, so good question. And basically we can kind of fabricate that table a little bit. Because we kind of know like certain things. Where it gets a little weird is on like the essentially like the days of the year. But we can get close. But
Yeah, it looks
also,
like it's like about 52. So I think if we put 52, that should work. It's just
yeah,
the gardeners do things by week. Like if it's the 30th week of the year, then this is a task you should be doing, or this was what should be in the seed beds at this week instead of the date, because the date fluctuates.
yeah, got it. So yeah, I would kind of just and that's a good question. So like if it were me, what I think I would do is I would have like a year table that has, 2023, oops, 2023, 2024, 2025, etc. And then you could have a week table. And the week table could be assigned to each of the years, essentially, or you could duplicate it. So because basically we could go through 7, whoops, 8, 9, 10, 11. Because do they plant year round?
Yes.
Okay. Yeah. So basically, we need to generate 1 through 52.
So I do like insert into planting week values 1, 2, 3, like did I literally do that?
No, so that'll because basically when we say like insert into, like let's say let me just build a week table real quick. So create table. Let's first say use playground. And then I'm going to say create table. Really, we'll call it a calendar week. And then we can do we'll just call it a
Call it planting week. Okay.
all right. So we can create something like this. And really what I do, I think, is I would put in, like I said, a year ID here. But what we could do is let's just say we were going to define this. Let's just say we're just going to keep it simple for now.
Yeah, because like I'm trying to insert everything from my because I transitioned over my EID and now I'm trying to insert things in my table. So it's like I guess I could recreate my tables.
No, we can make this work because basically this is what when you insert it, this is what it'll look like. So we'll say yearly week number, something like this, and then values. And it could be 1, 2, 3. So like that'll essentially put the, because if you're just inserting one, select everything from calendar week. So that's kind of how you can get it in there. Because basically, like if we had 2 columns, you would put a comma in here with like, like let's say we were doing start day, right? Something like that. Like if we were going to have like an additional column in there. But just for putting those ones in there. You can do it like that. But if you want to save some time, we can do a shortcut.
I like shortcuts.
Oh, safe update mode. File. Let's see, edit. Reconnect. There we go. All right. So basically I just emptied the table. So basically we can cheat. And I remember there was an exercise one time where we did where we generated the numbers 1 through 100.
Mm-hmm.
So
yeah.
basically I'm going to do that same exact thing where, you know, I select 1 as D1, digit 1, union, 2, oops, select 2. Let's just put this all in one line.
I started doing that, but I couldn't figure out how I could put that in the values of my insert.
Yeah, so basically we'll do this. Select, and we really only need to go to 5. So there is that one. So that'll produce all of our first digits. And then the second one will need to go through 9. So
I put it in Chat GPT too, so I'll copy and paste it in when it's done. But if you don't use Chat GPT, it's a really good way to write code.
I don't use that.
anyways, then we can just take and cross join this. So we're going to say so then we can select everything. Instead of selecting everything, we can say select concat. Guess we need a 0 here, don't we? There we go. And we'll just do this. We'll just say +0. There we go. So So this generates all of our numbers through 60 or 59 essentially. So then because since we only need, let's just say 50, let's just say 55. I think can only be up to 53 weeks in a year, but don't quote me on that. I know it fluctuates from 52 to 53. But we can basically say where week number between 1 and let's just say 55. And what changed? Must have deleted something. There we go. There we go. So then we have our week numbers. So now just to get it in there, we can just kind of use the select statement just like we would here. So we can just say insert into calendar week. And when we're doing it from a select statement, we just got to make sure it returns the same number of rows. So in this case, just like we did here, but instead of listing out the values, we're just going to specify it. So we say insert into calendar week, yearly week number, and then we just have our select statement. We can run it. And then when we select everything from calendar week, we should have them all there.
That's what I started to do, and I thought, oh, maybe I'm off.
Can't you do a loop in SQL as well or no?
You
Like a for
can,
loop?
you
Yeah.
can. They're just a little bit more involved,
Okay.
so to speak.
Amy, if you see the chat, I put what the chat GPT started. It stopped at week 38, but that gives you the actual days of the week and stuff too. If you want the start date and end date to be exact, it's what it's saying.
Okay. Insert into weeks. Week number, start date, end date. Okay, so I just need to cancel, like delete one of my current ones. Thank you. Thank you both.
Well, it should be. I didn't double check it, but I mean, it should be pretty accurate as far as the first week really being, February 2nd or January 2nd to the 8th. And then it just stopped at week 38. So you'd have to look at the calendar to finish it, but it gives you the pattern there.
Yeah.
If you wanted actual, days of the week for the real job.
And what we could do is we could get clever. So once we generate this week number, so here we have the week number. So what we could do is we could even take this a step further. And call week number. So what we could do is we could get the week number. And then what we could do, this is going to get a little wild. But basically what we could do is we could get the total number of days between, essentially that each week represents, and then we could do a date diff essentially. So like right now I'm getting the week number. So what I'm going to do is I'm going to take this same formula and I'm going to, instead of plussing it by 0, I'm going to multiply it by 7. And I'm going to call that cumulative end day count. Because if we're looking at this, let's see, so we get week number and then cumulative end day. Let's call it number, end day number. It's not a count. Then we kind of say like, okay, this is essentially the week. So, and this is where we have to start asking some questions like when does our week start, right? So like if we were to look at a calendar in January, it technically started January 2nd. So what we could do, now that we have the cumulative day number, is we could say, okay, starting from January 2nd, 2023, 0102, we want to add some stuff. So date add. And if we take a look at the date add function, we can basically give it a day and say add something to it.
7 days.
Yep. So, but what we'll do is we'll say date add, and then we're going to add our cumulative and day number. And we're going to see like what this says. Because this should tell us exactly, let's see when the end was. So let's just try this, cumulative end day number. So we're going to say interval day. So let's see what it says here. So that is the 9th. So if we go back, look at January. And what do you know? The 9th is actually the beginning of the next week. So what we're going to do is we're going to say cumulative end day number is equal to this minus 1, essentially. So now it's the 8th. And then if we wanted the cumulative day start, we could do the same thing. Yep. So we'd say minus 1 multiplied by 7. And essentially do the same thing, but instead of the end day, we'll say start. See how we did. Yep, that's exactly what we want. So there we go. Week 1, and we can take out this now. Doesn't matter. So week 1 should have gone from January 2nd to the 8th. 2nd through the 8th. 9th through the 15th. 16th through the 22nd. So that's a Monday through Sunday calendar, essentially. But yeah, what's cool is you can, just by kind of like generating a bunch of numbers, we can essentially build all that out.
That's cool. So it's another stupid question, because my stupid questions help other people to feel really smart. I've never been able to like cut and paste anything that's been shared with me out of chat. Like I can't like cut it and paste it into a Word or anything like that. I've tried it before. It hasn't worked. I wanted to save y'all's notes here. Is there a way to do that?
If you hover over the bubble, there'll be like some little icons on the right hand side.
See, like a smiley face, add reaction, and reply.
Do you see like 3 dots?
When I hover over the chat,
Yeah, like over the message. Yeah, there should be like I have a reply, a emoji, and then more. And one of the options there for me is copy.
that's weird. I don't have that. I just have the reply and the emoji.
Interesting.
That's all I have too. I wonder if you have more as a host.
Yeah,
Interesting.
and I can like highlight it all and Control C, but if I go to Word and try to Control V, it's not there.
Let me give you a paste bin here.
I can screenshot it.
Here, let's see if this there's a paste bin with the code in it. It should work.
Sure.
And then what's neat about this is now that you have the date, and I know we're just like embedding select statements here on top of select statements. I guess we can do without it, but we could add like a bunch of kind of like additional stuff here. Like we could say, oh, we want the year. We can say year of this as, the week year. Now we have the year. We could even do the same thing when we say month. So then you can add the month that it kind of hits. So anyways,
Can you format that month to like 0706?
You could, yeah.
I was trying to do, I couldn't figure it out. I tried to format and 2-character and it just wasn't working.
Yeah, basically you have to change it to text. So like we could say concat and then add, like a 0 essentially. Basically you have to make it think it's text, because the minute it thinks that it's a number, it'll take out the leading zeros.
But that would put 011 and 012 though, right?
Yeah. So you'd have to you could write like a case statement, or you could basically say case when it's less than 10, then concat a 0, else just leave it essentially.
Okay. Yeah, just use a really big camera to get around a really small problem.
Yeah. And really, like, what I would do is I tend to like them kind of left, just so I can do math. Like, so if I say, oh, I want the previous month, week month -1 essentially. So I kind of like them as integers. And what I would recommend is, let's call this as cumulative week number, because what's cool is we can always kind of deduce how many weeks are in the year with SQL, right? Like by doing like aggregation. So what we could do is we could actually make this this query really generate just tons of years in advance. So, you know, let's say we're
All
going to
this looks so easy. I say that like, oh yeah, it's like you think SQL.
anyway, so we can let's see here. Because that'll generate 1 through, technically we can go 1 through 999 weeks. Just with this query here. So let's do this. We're going to order by 1. So now, like, we could go all the way. Let's see, we're still going just into, never mind. We're just, because we're concatenating. So never mind. We're just going to go 0 through 99, but we could add like a third digit to this, you know, by essentially taking and just doing this. Anyways, you know, we could add any number of digits, basically get as big a number as we can to generate like lots of years in advance. And I call this cumulative week number because it's going to roll. It doesn't matter what year it's in. And then from there, if we wanted to kind of get, you know, exactly what the number is. So I'm going to just, the other solution to this is, so once we have this table, I'm going to say create table calendar as, just run that. So now we have this calendar table. So if I wanted to add like the weekly number in each given year, I could just, you know, do select cumulative week number, and then say, I want the year. Let's just do year. No, let's do cumulative week number. And then we have the week year. But I'm going to swap these. I'm going to take the week year out, put it up here. And then we have this cumulative week number. What I'm going to do is I'm going to use a rank function. And technically we could have done it here. Let's see if we can just do it here. So we have our week number, which is the cumulative week number. We have the week year. So basically what I'm going to do is I'm going to figure out like what week in the year it is. You know, because cumulative week number is just going to be 1 through 99. So what I'm going to do is I'm going to say rank, and I want to rank the week number. And I'm going to say over, and I mess this up. So rank is just empty. I want to rank, and what do I want to rank? Oh, I want to first partition by the year, so week year. So first I'm going to partition this by this, partition by this, and order by cumulative week number ascending. I'm going to call it intra-year week. And what do we do? Cumulative week number. Oh, it's just week number. There we go. So now for each given year, so for year 2023, we should see it go up to 52. And then for 2024, it will restart.
You just love this stuff, don't you?
It's anyways, yeah. Like I've had to build these before, and so you get pretty creative about not, you know, going into a spreadsheet and dragging columns down trying to make it work. Anyways, yeah. So anyways, there's that one. Lots you can do. What I love about SQL is like, especially like this data kind of fabrication. It's fun because just by kind of giving, you know, generating 1 through 99, we were able to basically generate like a whole calendar essentially, which is pretty cool.
Thank you.
Yeah, no problem. Okay, so now that we did the fun stuff, we'll talk a little bit about what's going on this week. So this week we're we're talking about transactions, and really the name for these are TCL statements, transaction control language. Basically, I don't know if you've had a chance to read the announcement, but they're kind of like our safeguards. I think of them a lot like save points or like save games. For those of you who have ever played a video game, you know what I'm talking about, right? Like in Skyrim, before you go fight the bad boss, you do a quick save, right? So that way if something bad happens, you can come back. And essentially that's the same thing we're doing here. And so the best example I have is money, because money is something that is important, and we like to make sure we get it right. So pretend that we're going to Little Caesars, and you want to buy a pizza. So you go in there and they ring you up for $12.50, right? That's essentially what we're showing here. They're going to ring us up for $12.50. Well, let's say we're at Pinky G's Pizzeria. So let's say that the bank is kind of doing this, right? So Pinky G's Pizzeria, they go to scan your card, right? And the way that the bank systems work, as we all know, is like, we have to take money from somewhere and then put it somewhere. And so it's really like a two, that's why they call it a transaction, because it takes two. Anytime we do a transaction, there's an exchanging of items. I give you money in exchange for an item. That's a transaction. And essentially that's what we're doing here. And in the banking world, or in a lot of these cases, we want to, the way it works is they'll take money out of your account, right? They got to make sure the money's there, especially when we're using plastic. So they take the money out, and then the bank will put that into someone else's account. And that ultimately takes two ledger items, right? So on your bank account, they're going to say, oh, I took $12.50 out and it was a debit, for those of you who are accountants. And then there's going to be a corresponding item that credits the pizza place's account by $12.50. And there's likely more to it than that, but essentially that's what happens. Well, let's say that you go to swipe your card. Let's say transactions aren't handled the way they actually are. You swipe your card. Let's say that the bank takes your $12.50 out, but then let's say the power goes out of the bank or wherever their computers are, right? And you can see here, before it was able to put the money into, Pinky G's Pizzeria, it fails, right? So let's say that you swipe your card and that happened. Well, on the point of sale system at the pizza place, it may say an error like, oh, the bank didn't tell us that this worked. So, try swiping again or something, right? So let's say you swipe again. This time the power's back on, everything works. Well, you get back home and you're like, oh, I should have enough money in my account to buy 2 more pizzas before the end of, before I get paid again. So, but so let's say you pull up your account, but now all of a sudden, instead of just seeing $12.50, you see 2. And that's a problem, obviously. And what's worse is if that were the case, that money would be just kind of in limbo. So what they did is, when whoever brilliant person invented SQL, they said, hey, we need a way to lump multiple things together. So then that way, we can do an all or nothing transaction, meaning it either works or it doesn't. And that way we don't get stuck halfway through. So I kind of have like an example here where it walks through like an actual function that will, run. So basically this first part of this function says, hey, look, begin is just like saying, hey, start the function. So it says, and then we declare an exit handler for SQL exception, which is basically saying, look, if an error happens, do this. So if an error happens, this is the code that runs. So what we do is we create a save point. And that save point is just like it literally is. It saves everything. So then we do two things. We take the money out of an account, put it back in. And if everything works, we commit. And if it commits, that means it's become permanent. The minute that it reads that commit message, it becomes permanent. But let's say that's like that same instance, something happens in between here. It's going to say, oh, an error happened, and it's going to display the errors for one and then roll back, meaning that anything that happened here will turn back to like it never happened before. But that's isolated to only the person that's doing it. So let's have a fun little exercise. So we know we created this calendar table. So first of all, I'm going to delete the calendar table again. Let's delete table calendar. But we don't delete, we drop.
I was about to say, I thought it was drop.
Yes, it is a drop. So we're
Delete
gonna,
clears the content, drop gets rid of the table.
yes, yep, exactly. Delete is a yard sale, drop is a burn your house down. That's the way I like to think of it. All right. So we have our new calendar table, right? So we can select everything from calendar. Here it is. Now, let's say that we want to do some manipulation to this. I don't even know. But let's say we're just kind of messing around. And I say, oh, I want to update calendar. And I want to, or let's say we want to try to add more years, right? So insert into calendar. Insert into calendar. And we're going to insert cumulative week number. Yeah, let's just do cumulative week number because ultimately we can always reproduce. Once we have the number, we can reproduce everything. So I'm going to insert into cumulative week number. And what are we going to insert? Well, we're going to insert, again, we're going to keep just hacking this thing till it's dead. Basically what we're going to do is we're going to take every number and we're going to add 100 to it. So that way we should duplicate all of our numbers except for obviously 100. So we'll handle that. So we're going to select cumulative week number plus 100. Or let's just do this. Let's just do plus 99. That solves the problem. So we're going to say cumulative week number plus 99. Now, we could run this, but what we're going to do is we're going to, I like to use transactions for when I'm doing this trial and error stuff. So what I can do is I can say, I can't remember if this one's
start transaction.
Yeah. That's one of the areas where things will differ between two systems. So I'm going to say start transaction, and you'll notice that it worked. It just says 0 rows affected. So now I'm going to run this. And oh, something failed. And it says unknown column cumulative week in there. And that's because we forgot the from clause, which would help from calendar. So let's run it. Okay. We ran it. It worked. Let's check. Right. So there we are. And if we're looking here, we go from 99 to 100 all the way to 198, which is perfect. So at this point, it worked the way we want to. So let's say commit. Right. So now it's permanent. So let's say, okay, here we are. We should now have all this data. But now we want to do the same thing, but we want to update it, right? So we're going to say start transaction. And let's do our same logic here. Well, first we need this. So we're going to get our cumulative start date and cumulative end date, which in this case, it's just going to be a lot easier. So we're going to say update calendar. set cumulative, or did we have cumulative start date and end date? I don't think we did.
When I was testing this, it seemed like I could only run one statement at a time. Like if you run on that cumulative, you can run it all day long on that line 106. And it'll just say commit, 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 but it really doesn't run the above. It just
Yes.
runs because it sees so it's not really running that whole batch like it's supposed to. It's just running line 106.
Yeah, so we can put them in a function to where it would run the whole batch, but really these are all individual statements. So if we just run this, it will just run a commit statement over and over and over. So it's not necessarily supposed to run the whole batch, so to speak. Because most of the time what we do is we throw that in a function, similar to like what we have here. So like if we were to,
how would it roll back though? Like in that one there, it wouldn't roll back because you're just running one function at a time.
in which one? In this one?
In your sample one, because you have rollback semicolon, so it's never gonna go back to that roll up unless you have. Well, in that one, I guess you're saying it's a function.
Yeah, because this one will, I built this as a function, so basically it will handle the account, but if there's an error, then it will hit this code essentially.
Okay, but without the begin and end, it's not a function, and we're just doing individual case statements. Okay, because I kept playing with this, and I'm like, it's not really working. It's just running one piece at a time.
Yeah, yeah. So because basically each one is its own kind of thing essentially. So let's pretend that we're trying to update the we need the start date and end dates. So we're gonna say set start date equal to, and in this case we're gonna use our same little math here. So first we need the cumulative week number X7 for the start date. Let's see, -1 X7. Yeah. So that's our start date. And so then we can say so let's just say that we just ran it just like this, right? So I'm going to say start transaction. And I guess before I do that, I'm going to commit. There's one thing that we need to be aware of, and that is that Workbench has certain things that may do auto commits. So what we can do is we can go to preferences, and forgive me, I may have to look at this just a little bit. SQL execution. So new connections use auto commit. So basically most of the time you want this on, but when we're learning about committing, I'm going to turn this off. And I'm actually going to go home to say open a connection to get a new connection. And I'm going to do one just kind of as a test. So I'm going to say create table hello as select hello. Something simple. So now I can see what's in there, select everything from hello, and I'm just going to test it. So I'm going to say begin transaction. Sorry, start transaction. And then I'm going to say update hello. Set T1 equal to goodbye. Guess we'll just say good. And then I'm going to say, so I can select it, We see good, but then we're going to say roll back. And we're back to hello. So I know I'm not auto committing because I was able to run this and then essentially revert it. So we're good there. So what I'm going to do now is I'm going to start this transaction. I'm going to run this. And it all worked. So we think we're good, but we always want to check. And in this case, it should be the same. But like, what if like, oh, I suddenly realized that I forgot to put a where clause because I don't really want to update all the other stuff. I only want to update the one. So we're going to roll back. We should see all that data disappear for those other ones, which it did. And then we're going to say, oh, we only want this where start date is null. So that way we don't override everything. So now we're going to begin our transaction, run this, let's check it. You know, we verify it. Yep, looks good, cool. And then instead of running the rollback, we're going to run the commit. So there's that. So what I'm going to,
It's kind of like a save, right? Like,
yeah, exactly. Yep.
Yeah.
Yep. It's just like a save, essentially. Basically, anything, if I make that transaction, anything that I do, you know, is essentially logged. And then if I say rollback, it deletes it all. If I say commit, then it makes it permanent by essentially removing the log. So that's the only thing. So whenever we do a transaction, I always picture it like a spinning wheel, right? Like a what are those called? Merry-go-rounds. You know, where they each have like the Wheel of Fortune type style. Every statement we do adds a chunk to that Wheel of Fortune wheel. And then when we roll back, it basically just rolls it back to where we were and, you know, deletes everything on the wheel. And that's actually a real thing. It's called the redo buffer log. It is essentially what it's doing. Redo buffer log. So the redo buffer log is essentially like the wheel that essentially runs the reverse statements. So like here's an image maybe. This might be way too technical for what we're looking for. So yeah, you can kind of see as we're writing things to the database, the redo buffer log is going to get larger and larger, which means that we take up space. And then as soon as we do a commit or a rollback, it'll essentially wipe this clean and undo what happened, essentially. And like I said, the downfall of that is every time we do a statement, it has to track all that. And you can imagine that's a lot, right? Like it has to be able to undo all that. So, you know, the more we do on a transaction, the larger that redo buffer log gets and the more space is taken up on that server process. So
You can also create a save point too, right? If you're doing 10 transactions, after transaction 5, go ahead and save it, and then 6 through 10 commit.
yeah.
So it tracks it up until a save point or the whole entire thing, right? However you set it up.
Yeah, and basically the save point is you know, it's like we could say save point SP1. It's essentially the same thing, but we can roll back to a specific save point. So I could say roll back to SP1. And so then that way, like if we needed to have like a couple different like points of failure, essentially, you could like, you know, get halfway, do a save point, try to finish it. And if something fails, roll back to halfway, essentially. So basically they're just named transactions, essentially. So then you can roll back to specific ones.
So if you have save point 1 through 5, you can do your rollback all the way back to point 1, even though you saved it at 1, 2, 3, 4.
You know, let's try it. That's a good question. So let's just take our little hello world example here. We'll just make it say, good job, Bob. Okay. So we're gonna let's reset. So we're back at no wait, now we're back to where we were. Now we want to go back to hello. All right, so we're at hello. So I'm going to create a save point, change it to good. And let's just keep a select statement down here. So we're good and save point 1. So save point 1 is hello, actually. So now we're going to go to save point 2 and change it to job. So let's roll back to, well, let's check it. So we all see job. I'm going to roll back to save point 1. We're back to hello. So let's just commit. Let's start over. So should be hello. Save point 1 to keep it at hello. We're going to go to good. There's good. We're going to go to save point 2, do job. And now we're going to roll back to save point 2. We should be back to good. I'm going to roll back to save point 1. We should be back to hello. I think once you roll back, though, you can't come back. So we can move backwards, in our chain of save points, but we can't move back forward, if that makes sense. But yeah, basically each one's an incremental step, essentially. And at any point, until we do something, we can always roll back to a previous one. Good question. So anyways, that's transactions. Just know that when you're playing with them, you do need to turn off that auto commit in Workbench. Most IDEs do have an auto commit. Obviously, the command line does not. So if you just want to kind of play around with it, maybe command line will just be easier. But anyways, save points are nice. Basically, anytime, like even for your final projects, if you're changing things, you can use transactions, start transaction and then check, commit, or rollback. So those are always handy, even just for data administration tasks. But also for, if we're putting in data that requires multiple, we can make it kind of have save points and transactions to kind of help keep our flow working as possible, right? There is caveat to that. So only certain things can be rolled back. And some things cannot. So let's take a look. MySQL rollback. So basically DML operations, so data manipulation languages, statements, can be rolled back. Some other things cannot. So DML, there's a couple different types: DML, DDL, and TCL. So basically, DDL is data definition language. So if I drop a table, I can't roll that back, essentially. And we can kind of see that here. So DDL is create, drop, alter, truncate. Truncate basically removes all the tables, all the data from a table, but that cannot be rolled back. So people use truncate when they really want to just like wipe it clean without any, if you're not going to have to undo it, you truncate because it's faster. But DML statements, you can do insert, update, delete, and that can all be rolled back. In fact, one of the top interview questions, if you ever go to interview for a job and they're asking you about SQL, one of the most popular questions is, can you roll back a truncate statement? Or which statement that deletes records can be rolled back? You'll get asked that, and basically you cannot roll back a truncate. So, anyways, keep that one close to the chest. And the way I like to think about it is, you know, like I said, when we're talking about the difference between delete and drop, the way I keep it straight in my head, like I said, I always go back to the house analogy. So we have our house structure, right? And then we have the contents inside of our house. And it's just like a table. A table has its structure, and then it actually has contents. And the contents are the actual records inside that table. The structure is the column names and the data types. So we can have an empty table that doesn't have any content. A truncate statement, or the data definition language, DDL, is essentially defining the house. You know, it's the construction job. You know, any major construction, that's DDL. You're dealing with the structure of the house, and essentially, you know, we can't fix that. You know, if I tear out a wall, like, we can build a new wall, but I can't just undo it, essentially. But our data manipulation language, we can undo, you know, essentially. So that's kind of how I keep it straight in my head. Truncate deals with the structure. DML deals with the contents, and we can undo anything that deals with the contents.
Good explanation. Thank you.
Yep. All right. So we're out of time. I don't want to keep you any longer. Do you guys have any questions?
No, we'll just keep trucking along.
All right. All right. Well, if something comes up, let me know. Otherwise, hope you guys have a great week. And yeah, we'll talk soon.
Thank you.
Yep.